it so that you may come back to it later if you need, and so others who may have missed out on today's events will be able to come and watch it. Thank you. So now, at this time, please mute your mics for the best sound experience, otherwise the feedback could interfere with information we will be sharing. We'll be sending the 1324 room link on the chat so that you may connect to your session if you're here for Math 1324. Ms. Patricia will be sending individual messages to everyone to gather your student ID numbers to sign you in. Without further ado, I'll pass it on to our presenter so that we may begin.
Hello, everyone. Happy Friday. All right, so we're gonna get started. I know Mr. Carizales covered some of these topics last week, but we'll go into them a little bit deeper. And so let's get started. Okay, so last week you were learning about exponential and logarithmic functions. And so we're gonna go ahead and solve these logarithmic expressions. So here we have log 5 of 125, and we want to know what it's equal to. So one of the ways that you can do this problem is if you look at the base here is 5. You want to ask yourself, what exponent does 5 have to have so that we get 125? So 5 times 5 times 5 would give us that 125. A second way to do this is to change it to exponential form. And if we do that, then we're going to end up with the base is 5. And I always like to say the log is equal to the exponent. So that means that x will be your exponent. And then we have 125. Then we can use the 1-to-1 property that you saw last week to change 125 as 5 cubed. And the 1-to-1 property will allow us to set the exponents equal to each other since the base are the same. So here my answer would be x equals 3. Okay, so we look at the second one here. This one's a little bit different, so we can't do the first option. We can't ask ourselves, well, I guess we could ask ourselves, what power does 2 have to be to give me a 25? And so that's not going to work out, right? So we can change this to exponential form. So our base here is 2. So we're going to write our base, which is 2. And then the log is equal to the exponent. So since this log is equal to x, that means that x would be our exponent. And then we have 25. So here I cannot use the 1-to-1 property because I cannot change the 25 so that it has a base of 2. So we could use a calculator to help us with this, and then later we're also going to learn another way to do it without the calculator. So here I have a picture of 2 calculators. On the right side, notice that I can enter the problem log 5 of 100, but on the left side, there's no room for me to enter that base. So if you have a Casio calculator, more than likely you're going to have that opportunity to enter the problem the way we see it. But if you don't have one, it's okay. You don't have to go buy one. Your TI-83 will still do the work. And this is what we're going to be using is the change of base so that we can change the base to a base that's in our calculator, in any calculator. So we're going to go from any base, we're going to change it to a base 10 or a base E. So the way we're going to do that is if we have a logarithm, so here we have log A of x, we're going to change this to a log of base 10. So we're going to have log x divided by log A. Or we can change it to a base that has, to a log that has a base E. So this we would write as natural log of x divided by natural log of A. Notice that your base is the one that's going to be in the denominator at all times. So how does this work? So here it says evaluate the logarithm using the change of base formula. So we cannot enter log 311 into our calculator because the base is not 10 or it's not E. If you have a Casio one, then you could do that, but we're going to say that we're going to go ahead and use the change of base. So here I can rewrite this log 311 as log 11 divided by log 3. So now the log 11 and the log 3 have base 10, which means that I can use my calculator. In our calculator, we can type it in as log 11 divided by log 3, and then this is going to be our answer. So sometimes, depending on your calculator, you might have to enter it a little bit different, especially if it's a scientific calculator. In a scientific calculator, sometimes you have to enter the number first and then press the log. So play around with your calculator and then see which way is the way that it wants it to be entered. Okay, so let's look at log pi of 0.5. So we want to change that. Our base is pi, so we cannot put it into our TI-83 calculator, for example. So we use the change of base. So here we're going to end up with log of 0.5 divided by log pi, and that's going to be approximately negative 0.606. Okay. Now we could have also, instead of writing it as log 0.5 and log pi, we could have used natural log. We could have said natural log of 0.5 divided by natural log of pi, and you would still end up with the same answer. Any questions on that one? All right, so last week you also maybe saw some of these properties, and so we're gonna do some problems with these properties. Okay, so let me go ahead and go on. So it says use the properties of logarithms to write the logarithmic in terms of log 5.2 and log 5.3. So here we have log 5.6. So what we could do is we can change the 6. We can rewrite it as 2 times 3. So log 5.6, we can write it as log 5.2 times 3. And then we can use the product rule. So the product rule tells us that if we're multiplying two items, we can separate it as addition. So log 5.2 times 3, we can rewrite it as log 5.2 plus log 5.3. Okay. And if you're able to simplify without using the calculator, then we can do that. But here we can just leave it as is. All right, so let's look at this one. So we want to evaluate this without using the calculator. So we have log 4 of the cube root of 4. So first, any roots that you have, if you have a cube root, a root, you want to change them to exponents. And those exponents would become a fraction. So the cube root of 3 is the same as the exponent of 1/3. So here I have log 4 of 4 raised to the 1/3. So then I can use the power rule. Remember, the power rule says that we can take the exponent to the front of the log. So I'm going to take this 1/3 to the front of the log using the power rule. So we have 1/3 log 4 of 4. So now from section 3.2, we saw this property here, log 4 of 4. So hopefully that property is going to be this one here, number 2. So notice the base is the same as this number, so that becomes a 1. So log 4 of 4 is just going to be equal to 1, and then 1 times 1/3 is going to be 1/3. So this whole log is equal to 1/3. Any questions on that? Okay, so let me go on. So find the exact value of the logarithmic expression, again, without using a calculator. So again, here we have a 4th root. So I can change the 4th root as an exponent, which is going to be an exponent of a 4th. Then I can use the power rule so that I can take that, well, let's simplify the parentheses and the exponent here. So you have an exponent raised to another exponent. So we multiply the two numbers to get e to the 3/4. Now I can use the power rule. So the power rule says to take that exponent to the front. So we have 3/4 natural log of e. So remember that natural log of e is actually the same as log base e of e. So since these two numbers are the same, we can use that property number 2 again. So natural log of e is always going to be 1. So anytime you see ln e, that's always going to be a 1. And then times 3/4, we get 3/4. Let's try the next one. So natural log of e to the 4th plus natural log of e to the 8th. We can apply the power rule, get our exponents to the front of the log. And so here we end up with 4 natural log of e plus 8 natural log of e. So what is natural log of e again? That's going to be a 1. So we get 4 times 1 plus 8 times 1. So 4 plus 8 is equal to 12. Any questions on this example? Okay, so here we have another one. It says use the properties of logarithms to expand the expression as the sum or difference of multiple logarithms. So we're starting with one logarithm and we want to expand it into multiple. Okay, so first we can see what's happening with z and z minus 1 to the 4th. They're being multiplied. So we can use the product rule. And the product rule tells us we can separate it as natural log of z plus natural log of z minus 1 to the 4th. Then you want to ask yourself, can I simplify further? Well, I see an exponent here, so I can apply the power rule. And the power rule says that I can take that number to the front. So I'm going to have natural log of z plus, I bring my power to the front, 4 natural log of z minus 1. Any questions on that one? Okay, so let's try this one. Same thing, you have one log, but you want to write it as multiple logs. So here we're dividing two items. So we can apply the quotient rule first, and we're going to separate this using subtraction. So we have log 5 square root of x squared minus 9 minus log 5 of 4. Then I have a square root here, so I can rewrite the square root as an exponent. And that exponent is, instead of the square root, I can write it as a half, a power of a half. So now this power I can bring to the front using the power rule. So we're going to have 1/2 log base 5 x squared minus 9 minus log base 5 4. So now we look inside the parentheses here. We have x squared minus 9. We can rewrite that as, if we factor it, as log 5 x minus 3 times x plus 3. So now I'm multiplying two items here. So I can use the product rule again and separate it with addition. So I'm going to have log 5 x minus 3 plus log 5 x plus 3. But the half is being applied to both of them. So we have 1/2 log base 5 of x minus 3 plus 1/2 log base 5 of x plus 3 minus log 5 4. Okay, so you want to simplify as much as you can. Any questions on this example? All right, so here's another one. So here it says x cubed divided by y cubed times z to the 4th. So notice that x cubed is being divided by this here. So we can apply the quotient rule. So now we're going to have log 8 of x cubed minus log base 8 of y cubed times z to the 4th. So if we look at the second log here, the y cube is now being multiplied with the z to the 4. So we can simplify that using the product rule. So we end up with log 8 of x cubed minus log 8 of y cubed plus log 8 of z to the 4th. Okay, so now we have a minus in front of the parentheses. So let's go ahead and multiply that negative into the parentheses. And so we end up with log 8 x cubed minus log 8 y cubed minus log 8 c to the 4th. And what is the last thing that I can do for each of these logs? Any ideas how I can simplify one more step? So they all have what? Exponents. So I can bring those exponents to the front using the power rule, right? So let's go ahead and do that. So the 3, I can bring it to the front. So I have 3 log 8x. And then this 3 I can bring to the front. So 3 log 8 base 8 to the y. And then 4 would be 4 log 8z. Okay, any questions on that one? All right, so let's change this. All right, so here we want to simplify again, but notice that x to the 7th times x to the 5th plus 7, they're all inside of that 10th root. So we want to get rid of that 10th root and rewrite it as an exponent. So the 10th root we can write as an exponent of 1/10. And so now we can work with the parentheses here. So these are being multiplied. So we can use the product rule or the power rule. I guess we can use the power rule first. That way we can leave these guys by themselves. So let's apply the power rule. So here we're going to have 1/10 to the front. And then we have this information. So now we can use the product rule to help us separate what's in the parentheses here. Okay, so the product rule tells us we can separate by using addition. So we're going to have 1/10 of the natural log of x to the 7th plus the natural log of x to the 5th plus 7. Let's distribute that 1/10. So if we multiply it in the parentheses, we get 1/10 natural log of x to the 7th plus 1/10 natural log of x to the 5th plus 7. And that would be our answer. Okay, so the last one was, I keep forgetting my exponent here, right? So the 7, we can apply the power rule, bring it to the front, so we get 7/10. All right, so in the previous examples, we had one log. We wanted to write multiple logs. Now we have multiple logs, so we want to write it as one log. And the reason we're doing these, going from one log to multiple ones or multiple to one, is because in a little bit, when we solve equations, these properties will help us to solve those equations. So if you have multiple logs like we do here, and you want to write it as 1, you want to start off with any coefficients in front of the log. So like here I have a 9 in front of this log. So if we think kind of going backwards, how did we get this 9 in the front here in the first place? Okay, so this 9 has to be an exponent so that it could come to the front. So we can always make sure that we change these numbers in front of the logs and rewrite them as exponents. So we're going to rewrite that as an exponent. So we have log 6 of 3x minus log 6 of x to the 9th. Okay, so all I did is bring the 9 to be an exponent. Now this first log is being subtracted with the second log. So if you have subtraction, then we can combine it using the quotient rule. Okay, so the quotient rule says that that we're going to be dividing. So the subtraction here becomes, we can write it as division. So we're going to have 3x divided by x to the 9th. So we went from multiple logs to one log. And then we can simplify. So 3x divided by x to the 9th is going to be 3 over x to the 8th. Okay, so let's try a couple of more. So here on letter A, I have 3 different logs and my base is 10. Okay, so first you want to check, do you have any numbers in front of the logs? And we do. We have a 6 and a 7. So first let's take care of those numbers by making them exponents. So we can change those to log x minus log y to the 6 plus log z to the 7th. So we're doing that by using the power rule in reverse, right? So now we need to combine these. So I'm going to combine the first ones here. So log x minus log y6, those are being subtracted. So we can use the quotient rule. So we're going to write them as division. So we have log x divided by y to the 6th plus log z to the 7th. So now these are being added, so we can use the product rule and write them as multiplication. So we're going to have log x divided by y to the 6th times z to the 7th. So if we simplify, then we get x times z to the 7th divided by y to the 6th. Okay, so here I started from left to right to combine my logs. Now let's look at letter B. Now if you notice for letter B, you actually have parentheses. So you want to make sure you do the parentheses first and then apply the other log. So we'll work with the parentheses first. So we have natural log of x plus 1 plus natural log of x minus 1. Since these are being added, we can use the product rule to combine them as multiplication. So we have natural log of x plus 1 times x minus 1. And we can actually simplify that so that we have, if we multiply it out, combine our like terms, then we get x squared minus 1. Now this is being subtracted with this logarithm. So since they're being subtracted, we can use the quotient rule to write them as division. So we have natural log of x by x squared minus 1. Any questions on that one? Okay, so now let's look at some equations. So we have 2 to the x is equal to 4. So to solve these, again, there's going to be different options for you. And so here I'm going to go ahead and use the one-to-one property. The 4, we can write it as a number with base 2. So that's going to just be 2 squared is equal to 4. Since the bases are the same, then we can set the exponents equal to each other. So we get x is equal to 2. Okay. So if you're able to change the numbers so that they have the same base, then the one-to-one property is going to come into play and sometimes makes these problems a little bit easier. Okay, so here I have a natural log of x minus a natural log of 13. So the one-to-one property that we're using for these exponential functions in letter A can also be applied to the logarithm. So in the logarithm, what we can do here is add natural log of 13 on both sides. And so the one-to-one property for logs says that if you have a log with the same base on each side, then we can set x equals to 13 and get our solution here. But they have to have the same base. Okay. So now for letter C, there's no way that I can make 13 to have the same base as E. So one method we can use is we can multiply by the natural log on both sides, or you can multiply by a log. It doesn't matter. But since it has an E, I'm going to multiply by natural log just to make it a little bit easier. So natural log on both sides, natural log of e to the x is equal to natural log of 13. So now I can use a property here. I have an exponent. I can't do anything with x up here, so I want to bring it to the front. And to do that, I can use the power rule. So I'm going to take that x to the front. And so, or I guess we could use the other method. But here, let me write in what I was trying to say so that you can see why it becomes a 1 there. So here, if we bring the x to the front, then we have natural log of e is equal to natural log of 13. And natural log of e here is going to be 1. So x times 1 just gives you that x. So here my answer is x is equal to the natural log of 13. And then natural log of 13, you can use your calculator key, and that's going to be 2.565. Okay, so let's look at this one. Solve the exponential algebraically. Okay, so notice here that the base is e and the base is e. So since they have the same base, we can use the one-to-one property. and we can set the exponents equal to each other. So we get x is equal to x squared minus 6. Now this is quadratic, so if I want to solve for x, I need to have everything on the same side. So I'm going to bring this x to the right side by subtracting on both sides. And at this point, we can either try to factor, use a quadratic formula, or use any quadratic method. Okay. So this does factor as 0 equals x minus 3 times x plus 2. We can set each factor equal to 0, and then we can solve for x. So x is 3, and x is equal to negative 2. Any questions on that? Okay, so let's look at a couple of more. So here, we still want to solve for x, but notice that x is an exponent. So in order for us to bring it down, this exponential part has to be by itself. So the 3 to the x has to be by itself. So to isolate it, we can get rid of the 5 by dividing by 5 on both sides. So if we do that, 5 divided by 5 over here on the left side is going to give us a 1, so we're left with 3 to the x. And 20 divided by 5 is going to give us a 4. So now, no matter how hard you try, we cannot make this 4 to have a base 3, and we cannot make this 3 a base 4. So we need other methods. So here, what we can do is we can multiply again by the natural log on both sides. So we're going to go ahead and do that. As long as you do it to both sides, then you're okay. So natural log of 3 raised to the x power is equal to natural log of 4. Since I'm trying to solve for x, I need x to be down here, not an exponent. So I can use the power rule, and I can take this x to the front using the power rule. So now I have x natural log of 3 is equal to natural log of 4. Since the x is now on the level of all the other numbers, we can solve for it. So I'm going to solve for x by dividing by natural log of 3 on both sides. So we have natural log of 4 divided by natural log of 3. And so it does say to approximate your answer to 3 decimals. So you would enter this in your calculator. So be careful on your calculators with the parentheses. You want to make sure that your calculator, that some calculators are picky on how you enter information. So I encourage you to try this with your own calculator and see if you're getting this number. Okay, so the answer here is x is approximately 1.262, and this is the way that I entered it on the calculator. Okay, so let's try this one over here, letter B. So we're trying to solve for x. We need to isolate e to the x, so we need to get rid of this negative 9, and we can do that by adding 9 on both sides. So we get 9 plus 36, and this should be, this is wrong, right? So let me get my pencil out. Give me a second. So this should actually be e to the x is equal to 36 plus 9, right? Instead of subtracting it. So that's going to be 45. Oh, my pencil just went away. Okay, so now what can we do? And so this is probably going to still be incorrect. So let's go ahead and check. Yeah, so let me go back and we'll just work it up over here. And then Ruben will use his calculator to give us the final answer. So here we can multiply by natural log on both sides. Okay, so if you use the power rule, then here we bring the x to the front. And then this would be natural log of 45. We know that natural log of e is going to be a 1. Okay, so x is equal to natural log of 45. So sometimes people just they just do this, right? And you know that's a 1. So you can do that too if you like. And then I don't know if Mr. Carizales got an answer for us, but you would put that in your calculator and then you'll have your decimal. Okay, so let's keep going. Oh, look, I think I put it right on the calculator. Oh, okay. So let me go back. So that it was wrong. It was wrong here, but then I corrected it over here. So 9 plus 36. 9 plus 36 is 45. We took the natural log on both sides. So we get x is equal to natural log of 45. Put it in the calculator. So we get approximately 3.807. All right. So now we have a logarithmic equation. These over here were exponential. So now we're going to look at the logarithmic equations. Okay, so we have natural log of x is equal to -4. Okay, so one thing we can do is change this log to an exponential function. So remember that natural log is the same as saying log e of x is equal to -4. So your base here is e. The log is equal to the exponent. So since this log is equal to -4, that makes -4 my exponent. And then the other number here is x. So we enter this in your calculator, e to the -4, as I entered it here, and we get 0.0183. Okay, let's try a couple of more. So we're going to change this to exponential form. So again, this natural log is the same as log e of 3x. So your base is e. The log is equal to the exponent. So that means that this log is equal to 2.8. That makes 2.8 the exponent. And then we have the other stuff here, which is 3x. So we're trying to solve for x. So I'm going to divide by 3 on both sides. And then I can use the calculator. So I have e to the 2.8 divided by 3. So we get approximately 5.482. Okay, so for letter B, we have 5 minus 5 natural log of x is equal to 11. So we need to isolate the logarithm. So I'm going to subtract 5 on both sides. So we get -5 here, -5 here. So if we simplify, -5 natural log of x is equal to 6. And the natural log is still not simplified. We need to get rid of that -5. So we can divide by -5 on both sides. And then we can change it to exponential form. So natural log again is log e of x. Your base is e. The exponent's going to be -6/5 is equal to x. So we can put that in our calculator to get approximately 0.301. Okay, so now let's look at this other examples. So we have natural log of x minus natural log of x plus 6 is equal to 7. So here, since you have multiple logs, if we look at the previous example, if we have one log at the end, you can change to exponential function. Or if you have the same log on both sides, we can use the one-to-one property. So here I have natural log of x minus natural log of x plus 6. So I'm going to combine these two natural logs. Since they're being subtracted, I can use the product rule, the quotient rule, and combine them with division. So we have natural log of x divided by x plus 6 is equal to 7. And so by having one logarithm, it's going to allow us to change it to exponential form. So natural log is the same as log e. So this e is my base. The log is equal to 7. So 7 is your exponent of x divided by x plus 6. So we're still trying to solve for x. So we need to keep going. So I'm going to multiply by x plus 6 on both sides. So we end up with e to the 7 times x plus 6 is equal to x. We still need to solve the x. We need to have those x's together. So I'm going to go ahead and distribute e to the 7 into the parentheses. So e to the 7 times x is e to the 7x. E to the 7 times 6 is e to the 7 times 6. And that's equal to x. By doing that, I can take this term and combine it with this term over here by moving it to that side. Okay, so we're going to simplify here. So I'm going to move this x over here to the left, so I get e7x minus x. And I'm going to move this term to the right, so I'm going to get negative e7 to the 6. So now these two have x's in common, so we can factor out an x. So if I factor out an x here, I get e to the 7 minus 1. And so finally, if I divide by that parentheses, then I'll have x by itself. So divide both sides by e7 minus 1. So we end up with negative e7 6 divided by e to the 7th power minus 1. Okay, and so I showed you here how I entered my information. So first, I multiplied the numerator, and whatever answer I got here, I divided by my denominator. But notice I didn't round, so you want to make sure you don't round until the very end. Okay, so here I get negative 6.005. Okay, let's try letter B. And I guess and one more thing here. So you always want, whenever you're solving for x and using a logarithm, you always want to check your solution. So since the domain for logarithms is from 0 to infinity, you want to make sure that whatever you have in place of x here, that it's greater than 0. So if x is equal to negative 6.05, if we plug it in here, you end up with a negative, and so that's not going to be a solution. Okay, so this answer here is actually no solution, because you end up with a negative and your domain is actually from 0, from anything greater than 0. Okay, so let's try letter B. So here I have 3 natural logs. So on the right side, I'm going to combine these two. They're being subtracted, so I can use the quotient rule and write it as x minus 6 divided by x plus 6. And now I have a natural log over here and a natural log here, so they have the same base. So I can use the 1-to-1 property, and I can set x plus 9 is equal to x minus 6 divided by x plus 6. We're going to go ahead and multiply by x plus 6 on both sides so that we can start simplifying this. So we end up with x plus 9 times x plus 6 is equal to x minus 6. Let's multiply it out. So on the left side, x times x times 6, 9 times x, 9 times 6 gives us x squared plus 6x plus 9x plus 54 is equal to x minus 6. Combine your like terms. So, and then this is quadratic. So we're going to move everything to the left side. And so we end up with x squared plus 14x plus 60. At this point, you can use any quadratic method to solve the solve for x. So here I use the quadratic formula. So we have b is 14, so we have negative 14 plus or minus the square root of 14 squared minus 4 times 1 times 60 divided by 2 times 1. So if we keep simplifying, then we end up with a negative 44. Okay, so there's not going to be a solution. Okay, one more here. So we're still trying to solve for x. So since I have 2 logs, I can combine them. They're being subtracted, so I'm going to use the quotient rule. So I can write this as x divided by x minus 8. Then I can change it to exponential. My base is 9. So I'm going to write it as 9 to the half power is equal to x divided by x minus 8. And so 9 to the half power is the same as square root of 9. So that's going to be 3 plus or minus 3. And so let's solve for x. So here, if we multiply by x minus 8, so first, since I have a plus or minus 3, I'm going to set it up this way. One is positive and one is negative. So then I can multiply x minus 8 on both sides. And I get 3x minus 24 is equal to x. Gather your like terms. So I'm going to subtract x on both sides. 3x minus x gives me a 2x. And I'm bringing negative 24 to the right side. So I get 24. So I get x is equal to 12. And on the second one, we multiply by x minus 8 again. So we end up with negative 3 times x minus 8. So we end up with negative 3x plus 24 is equal to x. Subtract x on both sides, so we get negative 4x. Subtract 24 on both sides, so we get negative 24. So x is equal to 6. So the last thing you want to do here is make sure that x equals 12 and x equals 6 are solutions. So to do that, we're going to take this 12, plug it in for x here. That's going to be positive. And if I plug in the 12 here, 12 minus 8 is still going to be positive. That means that x equals 12 is a solution. Okay. So this is what I did here. Plugged it in. We get a 4. This 12 and the 4 are positive. That's what we want. So for 6, if we do the same thing, plug in the 6 here and here, we get 6. 6 minus 8 is negative 2. Since you have a negative here, then that means that there's no solution for x equals 6 is not going to be a solution. So you always want to make sure you check your answers, because in some cases, they might not both work, just like here. And I guess the last slide here is going to be, most of you will be taking exam 3 next week. And so we wish you the best for that. And we have about 17 minutes left. So if anybody has any questions, feel free to ask us. And we thank you again for joining us on Friday. I was going to say afternoon, but I forgot it's Friday at 11. So if there's any question, let us know. We're here.
Yes, thank you, Mr. Good. Thank you, Mr. Carizales. We do want to remind everybody about the previously recorded sessions, which are available on a YouTube playlist. We just shared that link for that. The session will also be available on that playlist later today. Also linked is a short survey to help us improve our TVE sessions. Please take a few minutes to fill out that survey and remember to send your student ID number to us before you log out. Ms. Patricia has been sending individual messages to everybody to sign you all in. If you would like to download a copy of the presentations, you can go to the top right corner and click on the box with the arrow going down while the presentations are on the screen. That's going to allow you guys to download the presentations. So before you all leave, I want to share the TVE sessions that we will have next week. Join us again next week at 11 a.m. for another Happy Math Hour. Math 1314 will be covering linear and nonlinear systems, and 1324 will be doing the Exam 3 review. Our 1 p.m. session will be on ATC Transportation and Training Center and other ATC programs. Thank you all for coming in today. We hope you all have a lovely weekend. If you guys have any questions, feel free to use the chat box or your mic. We hope to see everybody again for Happy Math Hour. We hope everyone has a nice weekend. Thank you, everybody.